Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BVD IITM Lucknow. The course today will take up KCE 076 Urban Transportation Planning. Today lecture is 35 in which we will cover land use transportation planning part 2. References we have taken Chakrabarti Partha and Das Animes, Principle of Transportation Engineering, Papacosta and Prevendas PD, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering, R. Srinivas Kumar, Introduction to Traffic Engineering, S.K. Khanna and Justo, Highway Engineering. Some material have been taken from NAPTEL and internet. The contents today we will cover land use and land cover, land use, accessibility, mobility, land use and transportation interaction, Hansen accessibility models, density saturation gradient method. So, we will take up one by one. Land, we are continuing from the previous lecture. Land use and land cover again. Land use planning is required to predict a spatial organization of population and economic activity in the region. Land use models serve two distinct purposes. First, forecasting total activity of an urban area. Second, allocating these activity among the predetermined set. Land use planning for a city is a complex task and need to be done very carefully. Changes in the land use pattern are generally irreversible. So, now come to the accessibility. Land use and transportation system are inseparably linked. The concept of accessibility consider the basic underlying relationship between the land use and the transportation. So, what is the need for land planning? We have discussed in earlier lecture also. So, we can see here in the this line diagram, this is the base year and this is the horizontal year, horizon year. First includes land survey, then travel survey, trip generation, captive model split, trip distribution, choice model split, route assignment by modes. So, we can see here in the horizon year, then this will include zonal trip ends by mode. This is your origin and destination volume by mode. This will be contributed by alternative transport system, and finally, the route assignment by mode. So, this is the picture which is clearly shown why land use planning is necessary. This is the land use cycle. What happened? This is the first one, this is the land use. Once land use or make provision for transportation system, then the trip will generate. and for trip transport needs, and for this transport facilities are required, which needs accessibility. So, we can see here this is the cycle. After accessibility of a place, the land value will increase tremendously in the urban area, and again the land use. So, this is the cycle, and the last product is increase in cost of land value. So, this is the land use cycle for the urban area. This is a transportation cycle, we can say also. So, accessibility refer to the ease of movement between places. It indicates a spatial relationship or a degree of connection between one location and all other location in a region. Accessibility increases either in term of time or money when movement become less costly. Also, the propensity for the interaction increases as the cost of the movement decreases. This is the inversely proportional. So, now come to the mobility. Mobility is the ability to travel from one place to the another in the urban area associated with the particular group of urban resident. This indicates the ease with which a person can move out depends on the performance of transportation system and ability of an individual. This could be measured in term of trip made by all modes. All modes are considered for the mobility. Availability of different 25 modes and gives some indication of the resources one can spend on travel. Often expresses in term of number of trips made by an individual or a household, or sometimes in terms of NP. The total amount of travel, number of annual kilometer per person, etc. So, this is the mobility. What are the disadvantages? Disadvantage of mobility measurement per capita trip. There can be many short trip or trip of all trip length will be given in same weightage. It can be affected by the distribution of population by the age group in the zone. For example, there will be a less number of trip produced by age group of 0 to 10, or we can say the 0 or 1 or 2 years infants not able to make a trip. Even at 10 years old have a very limited trip for just going to schools, etc. The mobility level in term of average distance travel per trip could be better measure than per capita trip. So, when mobility is expressed as a distance travel, then it is found that as the accessibility index increases, the mobility decreases. This is important. Accessibility index increases, the mobility decreases. Hence, distance travel is not actual mobility, but is a measure of mobility need. The concept of mobility has been used rather undiscriminately to refer to both supply side and demand side of transportation system. So, we can calculate the mobility accessibility by Black's accessibility, and this is the empirical formula. This is 18.77 minus 1.44 into mobility. So, by this we can calculate the accessibility. Land use and transportation interaction. Land use and transportation interaction is not as simple. It is a conducted through the travel behavior of individual, which is again linked with the several urban phenomena and the system. So, in this diagram we can see here, this is the microeconomic development, that is a major contribution in GDP of the country, employment rate and job creation, though it is a microeconomics development. So, we can see here, and this requires rural urban or urban urban migration. For the better facility in the urban area, rural peoples migrate from rural to urban area. So, here the population growth or decline and the household formation or losses, but generally in the urban area it is not possible. Next is the demographic changes and distribution. So, we can see here this needs land use, this will also needs land use, and land demographic changes and distribution will occur, and for this required transportation system, for even technology and infrastructure requires, then the transportation will require. Land use and the transportation interaction. Distribution of land use such as residential, industrial or commercial over the urban area determines the location of a human activity such as a living, working, shopping, education or a leisure. Distribution of human activities requires a spatial interaction or a trip in the transportation system to overcome the distance between the location of activities. Transportation system on the other hand determines the spatial development on the virtue of improving accessibility, which in turn determines the value of land and land use. So, we can see here land use, transportation interaction. We can see here accessibility, land use, then the attractiveness which moves or construction, location decision of investors. So, we can see here this is the construction, then moves, activities, car ownership, trip decision, destination choice, then mode choice, and of course, route choice will be there, link route will be there for door to door services. Then the travel time and distance and the cost will affect the transportation interaction. So, we can see here the broad shape of the transportation interaction, how one depends on the others. Now, come to the Hansen's accessibility model. Hansen demonstrated the location with the good accessibility had a higher chance of being developed at a higher density than the remote location. Designed to predict the location of population considering employment as a predominant factor in determining the location. The use of accessibility index, that is AIJ, AIJ will be equal to EJ divided by DI j to the power B. So, where the AIJ is the accessibility index of a zone I with respect to zone j. EJ is the total employment, Dij is the distance between I and j, B is an exponential. So, overall accessibility index for zone I will be equal to AI will be equal to sum over j, Ej divided by Dij to the power B. So, the amount of vacant land that is suitable and available for residential use is also an additional factor in attracting future population to a zone. This is referred to holding capacity, that is called HI. This is the holding capacity. The development potential of a zone Di will be equal to Ai into Hi. Here Hi means holding capacity. The population is distributed to zone on the basis of the relative development of the potential. So, we can see here the potential is Ai Hi divided by sum over Ai Hi. If the total growth in the population in the future year is Zt, then the population allocated to zone I will be equal to Zt will be equal to Gt, sorry, Gi will be equal to Gt Ai Hi divided by sum over Ai Hi or Gt Di divided by sum over Di. So, this is the population allocation zone for the growth, total growth in a population in the future. So, this is the Hansen accessibility models. We can define this accessibility models like this way. Now, come to the Putman's model, because land use is based on different models depending on the location of the urban area, location of the country. So, it is a locational model that forecasts residence and workplace. So, Ni will be equal to sum over j Ej P I by j, where Ni the number of persons living in zone I. Is a person working in zone J. Pi by j is the probability that a person working in zone J would choose to live in zone I. So, that is the human behavioral aspect of the user. So, Putman's models go on. P I by j will be equal to f C I by j, where C I by j is cost of time of travel between I and j. So, f C I j will be equal to C I j to the power minus alpha divided by sum over I into C I j minus alpha, where alpha is the cost sensitivity parameters. Now, come to the density saturation gradient method. This is based on regularity of decline in density and percent saturation with the distance from the central business district CBD. This can be used as a tool for analysis of existing as well as a future land use structure. The forecast is basically a trend projection of the existing land use and the density structure in the region. This requires more subjective input and allow only for a limited policy and other planning decisions. Density saturation gradient method, three empirical rules are used in this method. First, intensity of land use declines as the distance or the travel time to CBD. Suppose in Lucknow, CBD or the center of the city is suppose Hazratganj. So, the density of the population or the activities are more near to Hazratganj. As we go out on outer side or as we go far away from the Hazratganj, the density of the population or activity will reduce. So, the intensity of land use declines as the distance or travel time to CBD. If the travel time is more, the density will be less. If the distance is more, then the density will be less. So, the ratio of amount of land in use to amount of available land decreases as the distance from the CBD increases. This is quite clear. Ratio of amount of land in use to amount of available land decreases as the distance from CBD increases. The population of land devoted to each type of land use in an area remain stable. So, we can see here the density distance relationship is given by dx will be equal to d 0 e to the power minus b x, where dx is population density at a distance x from the city center. D 0 is the central density as extrapolated into the CBD of city. B, the density gradient or the slope factor. Holding capacity of a zone is given by SCI will be equal to Pi plus VID, where SCI is the holding capacity of zone I. Pi is existing residential population of zone I. Vi, vacant, available or suitable land in zone I, and D, it is a anticipated average density at which all future residential development will occur. So, density saturation gradient method, the percentage population saturation of zone I in a certain year will be equal to population of zone I in a certain year multiplied by 100 divided by holding capacity of zone I. So, we can calculate the percentage population saturation of zone I. Thank you very much. Thank you.